Awesome. Thanks so much for joining us today, everybody, and welcome to How to Get Started with Platform Engineering. So a couple housekeeping notes before I let the presenters take it away. We are recording this session today, and we'll be sending out a link to the recording after we wrap. And then another housekeeping note, so there is a Q&A box in your Zoom webinar panel. So use that Q&A box if you have any questions during our session today or anything that you want to ask our presenters, and we will follow up after our webinar. So, okay, I'll kick it over to Johnny to go ahead and get started and take it away.
Awesome. Thank you, Maria. Hello, everyone. I'm Johnny Dallas. I'm the CEO and co-founder of Zeet. For those unfamiliar, Zeet is the easiest way to adopt platform engineering and build an internal developer platform, which we'll get into shortly. Really excited to talk to you today about how you can adopt AI more easily in this world of platform engineering.
Hi, my name is Vasia Patov. I'm a senior backend engineer at CoreWeave. We're a GPU cloud compute provider. Yeah, excited to get into it. So we've been seeing an incredible amount of growth in the AI space recently. There's been massive demand for high performance compute, particularly for GPU workloads involving inference and training. From our vantage point as a cloud provider, we've been seeing an increase in not just the number and variety of customers deploying models, but also in the scale of the computing power demanded. For the record, this trend has started well before the explosion in popularity that we've seen recently of generative AI models. It's been going on for a while. Despite these recent leaps in the abilities of models, there's still a really big challenge around configuring and deploying these models at scale. We have to spend a fair amount of time and energy working with customers to help them get up and running on our platform and to help them debug configuration and infrastructure challenges. And we find that this is a really big theme in the space overall right now. Johnny, would you like to speak more to that?
Yeah, I think that as we see the AI world developing, so too new challenges appear. Our friends at Run AI recently ran a survey of various companies trying to adopt AI and what their kind of main challenges were around AI development. And it broke down into a couple of categories. I think what's first important to mention here is 88% of respondents admitted they are having major challenges adopting AI or developing on top of AI. And these challenges broke out into categories that are a bit different than kind of what we've seen or expected in the past. The largest category is actually infrastructure-related challenges at 54%, followed by compute-related challenges at 43%. Data-related challenges kind of come in next at 41%, which is one of the more shocking pieces here. As in the past, when people talk about building on top of AI, most of the challenges come from the data world. So I think what this is really interesting to see here is that really reinforces the idea that we need to build a strong foundation around infrastructure and around compute to be able to get the most out of AI and these compute changes. Now, as we dig into what those challenges actually mean, what does compute challenges mean here? What does infrastructure challenges mean here? There's a couple categories and specific things that emerge. I think in our work together, CoreWeave has been very well positioned to see what some of those are. Vasia, you want to speak to some of the specific challenges here?
Yeah, some of the main challenges that we've been seeing has been particularly around on-demand access to GPU resources. We see that 89% of companies in the space still regularly face challenges getting access to the compute that they want when they need it. And there's a clear trend toward growing capacity and infrastructure goals. And we see 91% of companies are planning to grow their capacity and scale.
So ultimately, the question that we're asking is, how are companies keeping up with this demand and how are they able to transition so quickly? There's companies of all sizes facing these types of challenges in that survey, from very large companies to early startups. And there are many specialized cloud providers like CoreWeave that are rising to the occasion to meet this demand. But oftentimes a limiting factor here is how quickly can a company take advantage of these new cloud providers, the new capabilities that cloud providers are coming out with. It's often limited by either their in-house DevOps expertise or infrastructure expertise, or simply knowledge around adopting multi-cloud. All that said, we do see a strategy that's emerging that's been proven effective for keeping up with new technologies and new cloud providers specifically, which is platform engineering. Now, I want to start off just with quick definition of what platform engineering is. Platform engineering at a high level, it's a discipline of designing and building internal developer platforms, tool chains, and workflows that enable self-service capabilities for software engineering organizations. What this means really is using a product or a platform instead of human-to-human interactions to scale infrastructure. Go to a service and click some buttons as opposed to open a Jira ticket or send a Slack message. Now, this idea is interesting because it's really at all different levels of maturity at different companies. Every team actually has an internal developer platform of some sort. Maybe it is Jira, and maybe it is a Slack message. That's kind of your way for developers to interact with infrastructure. But really this idea of platform engineering is let's put software in place and make all of these interactions happen through defined workflows. There's some very advanced versions of this. I think in the DevOps world, we see tools like developer portals like Backstage coming out, and platform orchestrators coming out that create this category very maturely. But at low end, we even see teams like adopting tools like Vercel or Passes as a form of an internal development platform. What's starting to happen now is the commoditization of using an internal developer platform, using a formal platform to do DevOps. As we see companies of all sizes building these and infrastructure teams really getting hands-on for how can we add more capabilities to this platform and thus to our development teams, we're seeing some really massive improvements in terms of how developers can iterate and take on these new capabilities. I think the DevOps world is an interesting one because it's always a bit difficult. I think Vasia, you're obviously extremely competent. You're working at a cloud provider. You definitely know how to do cloud. Do you have any stories of kind of a time where even you struggled with deploying or dealing with infrastructure?
Oh, well, absolutely. Yeah, deployment is still challenging no matter how many times you do it. There was a product I was working on a while back with a friend called JustPoker.games, and it's a relatively simple web app. It was running in a VM in the Google Cloud platform at the end of the day. Then when I started working at CoreWeave, I wanted to migrate it to Kubernetes. And there was a lot of challenges in doing that, just simply translating the various GCP abstractions to Kubernetes with respect to scaling, load balancers, and just how resources are consumed. And then relatively seemingly simple things like making sure that HTTPS is working and whatnot. It all took much more time and effort than I thought it would, when really just the actual application itself is quite simple. So when you get into more complicated deployments and applications, deployment and configuration only becomes more complicated as well. So yeah, it's definitely still a challenge always.
And I think the problem you're speaking to there is one of the big reasons that we see teams adopt IDPs or adopt platform engineering. There's, I think, several drivers that we see happening right now. The first one of which is engineering orgs need a self-service way to deploy these infrastructure services. I think you're able to go to Google Cloud and there's a bunch of buttons there, but you still have to spend a lot of time configuring all the details, like even HTTPS, to get your application production ready. And so a lot of engineering orgs are looking for a way to make that entire process simple enough that any developer can go in and deploy their own application without having to get bogged down by some of these details. I think another reason that we see IDPs really hitting the mainstream is under-resourced DevOps teams who have a lot to do and don't really have the time to improve their systems. With an IDP, kind of free yourself from some of this supporting of product devs to go and focus on how we can minimize costs, how can we improve our security posture, how can we focus on these core DevOps initiatives. Similarly here, we hear this pain actually from not just DevOps teams, but we actually see a lot of product engineering teams that really want to pull in IDPs or pull in this idea of platform engineering. And I think this pain is felt most when they feel like they're constantly being bottlenecked by DevOps teams. I know I've been on teams where I need to create a DNS entry and I submit a ticket and wait 48 hours and I miss a launch date because of it. It's a very frustrating moment. And so platform engineering is a way that you can make that entire process self-service here. One other kind of big category, and I think this fits into the AI world that we're seeing more and more here, is multi-cloud. When you are deploying across multiple clouds, you need a higher level platform that can sit across them and orchestrate common deployments in multiple destinations. Without that, you end up duplicating a bunch of your work and kind of building for one cloud and another cloud, and you don't really get some of the benefits of standardization at a higher level. Additionally here, specialized technologies like GPUs. I think this ties into the multi-cloud piece, but even as we look at other technologies, you need a way to push these into the platform without necessarily telling everybody, hey, we're moving completely out of this cloud provider. We need to go and learn this whole new stack. Running as a new capability in an existing stack that's familiar to your devs is a very simple way to push adoption. And lastly, one big reason that we see IDPs is teams that are looking to migrate either currently or in the future between cloud providers. No one loves vendor lock-in, and it's easier said than done to sit across multiple clouds or migrate between clouds. But by defining your infrastructure at higher level, by defining it in a platform, you're able to replicate and make any translations that are needed between different cloud providers. So we've seen many teams that will adopt an IDP as part of a migration process, migrate conceptually release onto the IDP, and then switch out the cloud provider underneath. Now, as we talk about IDPs and where it kind of sits in the stack, I think this is a really helpful graphic to understand where, at least at the company level, an IDP fits in. It really sits here between your developers and your platform engineers or DevOps engineers. I think there's a trend right now of that title changing. But this is really meant to be the interface between your devs and your DevOps, which is the main way that your whole engineering org interfaces with your cloud. Devs are able to read information out of it and make simple controls like, I need to push this commit, I need to rebuild this, I need to see the history, I need to view some metrics. And DevOps engineers are really able to focus on getting those capabilities into the platform. By creating this kind of line in between them, both teams are able to operate much more effectively, much more quickly on their own objectives. And the IDP itself is the only thing that actually talks to your cloud. I think we've all been in the spot where one dev has access to AWS and goes in and clicks a couple of things and messes it up. Having an automated system, that's the only way to talk to your cloud, really increases the standardization of your whole infrastructure stack. Now, as we have talked here about some of the reasons that people adopt IDPs and what it kind of looks like in the company stack, I think there's a couple of outcomes that we think are really important to know that you're doing this effectively. One piece is really centralizing this developer access. I mentioned a moment ago, we've seen many teams who go in and have every single dev with production access to a cloud account, and one disgruntled employee or one intern can go and have some pretty negative effects on your infrastructure. By having an IDP, the blast radius of every individual on your team is greatly minimized. Everything goes through your platform, and you can use your platform to enforce proper controls. Similarly, as we think about standardization here, production-ready configuration can get applied at the platform level, and then any of those changes are guaranteed to be in place. You're never going to have to worry about, hey, did my dev go and click EC2 spin up and then push with the wrong TLS version or improper security configs or something else that's going to hurt another team in your company. Additionally, by virtue of having a platform, one really interesting thing that we've seen has been this idea of opaque upgrades. If you're able to give simple building blocks in a platform, like, hey, here's a web service, and your product engineering team simply understands that as the abstraction they build off of, you can actually change out how that works underneath. We've seen some teams that make migrations between different runtimes, like Vasia, your point a minute ago about switching from EC2 or ECS onto a Kubernetes deployment. By defining it as web service, you can actually make those changes underneath, and infrastructure teams can make that change without the application team having to know or care. Additionally, I think as we talk about security, we're really thinking about how do teams know what's going on. You can have many of these controls and see exactly how your infrastructure is changing over time in one centralized place. At the end of the day, I think this really pushes for developer velocity to increase. Everybody should be able to ship more faster because there's not a human in the loop. Everything is self-service. DevOps are able to free themselves from being kind of the support role for devs, which is not really the intent of DevOps. It's very much how do we build proper systems in place. And one easy way to know that this is now an effective piece of your company stack is a new service gets deployed without any human intervention or without any, DevOps intervention. I think many of the success stories we've seen have started with an exec coming to us and saying, guys, we just had a hack week and a new dev pushed to production, and it isn't horrible. It didn't break everything, and it's not horribly insecure. It just happened over the weekend, and this is incredible. Now, as we've kind of talked about some of the outcomes that you can get from a really mature IDP, let's also talk about how you actually get there. It's not just pop in a SaaS and you're all done. I think there's multiple steps that we see as teams adopt IDPs at different degrees. The first we usually see is people adopting IDPs for the creation of new services. Like I mentioned a moment ago, the idea of we had a hack week or we have some new project we want to get out. We don't really have a ton of time. We don't really want to go through all the channels. We just want an easy way to create a new service. This is a great opportunity for bringing an IDP and deploy one properly. Already, this has a massive reduction in the workload of kind of a DevOps team. They don't have to worry about provisioning environments. They don't have to worry about how is this service going to go out. But as that service gets more and more successful, you start to roll out some of these standards across the rest of the organization. So once you've been able to deploy one service effectively, one or two services effectively within a given team, bringing in a second team really compounds the power of an IDP, because now they're able to reuse any of the building blocks that the last team built. If you designed an effective web service deployment, say, or a effective load balancer definition, now the next team can adopt those same ones. You don't have to redefine them all. We also see this be very helpful for migration of legacy services. Once you have more and more of these blueprints, these kind of building blocks built up, you can start to centralize everything into one common place. And I think the benefits of centralization in terms of infrastructure are many. You'll get consistent observability, you'll get consistent cost reporting, you'll get consistent interfaces into what is deployed and how. And so this is a kind of the trend that we see as teams look to adopt IDPs over time. Now, I've talked plenty here about what is an IDP and what is platform engineering at a very high level, at a conceptual level, but we do have some examples we can dig into. So I think we have an example with Tarteel here that we can dive into and see how they were effective with an IDP.
Yeah, absolutely. So Tarteel, it's an AI-powered app that lets you study the Quran. It follows along as users read and recite the text. It highlights words as they're being said, and then it flags mistakes in real time. Tarteel was pretty underwhelmed with their GPU selection. They experienced a lack of observability for workloads in their cloud, and they overall had an unoptimized solution. And so after these frustrations and challenges, they were led to realize that they might need to migrate their infrastructure.
This is an example of a team that did what we mentioned a moment ago. They did this kind of migration from one cloud to another cloud. And the way they were able to do this was first migrating onto an IDP. What you can see here is an example of a kind of IDP in a box, what we've built with Zeet. This is a very simple view, is a very simple setup. You can see there's a number of services deployed in a variety of environments, from a Node Express project deployed on a Kubernetes environment to a Node Express API deployed onto a Google Cloud Run. Now, what the Tarteel team was able to do was they were able to migrate from AWS to CoreWeave in about 1 or 2 days, which is pretty remarkable given that they were under real load, and deployed to multiple regions. So while this screenshot here is not Tarteel's account, this is very similar to the infrastructure setup that Tarteel has now. You can see it's very simple for them.
And yeah, speaking more to the Kubernetes aspect of it, deploying on Kubernetes can sometimes be relatively challenging, especially for those not familiar with its core concepts or abstractions. And so it's pretty awesome that Tarteel was able to migrate in just a couple of days using Zeet. And as you can see, this relatively thin configuration, we're not showing theirs exactly, but theirs is relatively similar. It translates to a lot of complexity under the hood on the Kubernetes side with respect to all of the containers, deployments, services, ingresses, rollout and scaling policies, and other infrastructure configuration that is taken care of for you that is ultimately adjacent to the high-level goals of the app. And so after the migration, Tarteel was able to meet their demand and serve about 1,600 requests a minute on average over 40 GPUs. And they experienced a 22% improvement in latency, as well as a overall 56% cost reduction after migrating. So that's pretty cool.
Yeah, it's remarkable to see kind of the scale they've been able to achieve and how many benefits they've gotten from CoreWeave, and really how quickly they're able to make this change. I think from start to finish, going from a message of, hey, we want to switch cloud providers to we're up and on prod, 2 days is a remarkable timeline. I know many teams that look more in the 2 months, 2 quarters, or even 2 years timeline when they're trying to achieve a similar migration.
Absolutely.
Now, when we talk about incredible stories, I wanted to spotlight another company, a much newer company called Leap. Leap at a high level makes integrating AI features into your app a breeze with an easy-to-use API, kind of an all-in-one API on top of many of the common AI features. Now, what's interesting about Leap is they're quite new. They're about an 8-week-old startup. They've got a team of about 3. But a few weeks ago, they had a tweet go viral due to a response from Elon Musk. They went from 0 to over 1 million impressions in less than 60 seconds. You can see the tweet here, just a yep. But I think I don't know if anybody's ever been in that position of being very, very early. I can't say I have, and get a massive influencer to talk about you. It creates a pretty insane spike in traffic, and that is a very difficult thing to handle. Thankfully, Leap was using Zeet and had a platform kind of in place on day 1. And so they were actually able to handle the scale. I think, Vasia, do you want to speak to some of the scale numbers that they achieved?
Yeah, sure. So this is a graph taken from Grafana that every customer would have access to their own organization. And just speaking more to the spike and the scale up, you can see 3 very thin spikes. And that is exactly what is so incredible, just seeing demand rise and then computing resources scale immediately to meet that demand. And so for these spikes specifically, the first one, we went from about 5 to 60 GPUs. Then the next spike is about 5 to 45 GPUs. And then the last one is from about 3 to 75. And these really thin spikes, we're talking about the order of about 5 minutes for the scaling to scale up and back down. And so, yeah, it's really cool stuff. The auto scaling capabilities of Kubernetes makes it possible to meet this kind of demand in real time. And here Leap was able to take advantage of CoreWeave's on-demand model. This means that they didn't have to reserve this capacity in advance at all. And so they really only paid for what they used when they used it.
So just as a recap here on Leap, because I really think this is an incredible story of this small team hopping on this AI wave, doing a great job of riding it when the tsunami of Elon Musk comes in, and they've got a massive spike in traffic, 0 to over 1 million impressions in less than 60 seconds, 8 weeks old, 3 people, not necessarily all even technical. And because they were set up with this stack of platform engineering on top of CoreWeave using Kubernetes auto-scaling, they were able to handle this. I think actually, I remember seeing the spike and I reached out to their CTO just to make sure that they were doing all right. I know that could be very stressful. And their CTO closed their laptop and walked away. He was so unafraid of the impact here. Now, Leap is able to, Leap is still live, still active. They handled the spike completely. They had no issues. And it was just incredible to see the scale they reached so quickly with 0 interruptions in use. Now, we both with Tartio and Leap, these are incredible stories of massive infrastructure scale very quickly and kind of the benefits of platform engineering in play. But they're really just 2 examples that aren't necessarily unique. Both companies trying to migrate clouds at a larger scale and small teams looking to make an entrance into the field are able to do so thanks to some of these technologies. Now, as a high-level recap, I think as we see this trend of AI being adopted more and more, both in the last couple of years before generative AI, but now especially kicked off by the generative AI boom, there are new challenges, especially in the infrastructure world. And with new technologies come new challenges. One effective solution to adopt new technologies and stay on top of this is IDPs that can make this infrastructure self-service and really speed you up to focus on your product roadmap, not the underlying technologies or infrastructure that power it. If you're trying to do this, if you're looking at how do I get to an IDP, how do I enable developer self-service across my engineering org, I think the best piece of advice we have here is look first at where your devs spending their time. Because remember, they're already technically have an IDP. It just might be Slack, it might be Jira, it might be Linear. And whatever that kind of most common task is, find a way to replace that with software. And you can know that this is working for you when a new team is able to get to production that's approved by all the necessary people without having to go and have any manual DevOps intervention.
All right, thank you, Johnny, very much for joining us today. If you're listening right now and are interested in or are actively looking for a platform engineering partner or for general guidance, we highly recommend Zeet. I'm actually using Zeet myself for one of my personal projects. If you are a current CoreWeave customer on the line, we'll include a link to where you can read more about our integration in the follow-up email with the recording. Johnny, any last words?
Thanks, Vasia. I think hope that everybody here enjoyed listening to us talk about AI and platform engineering. If you're interested in learning more or adopting any of these technologies, feel free to visit us at zeet.co or reach out to us directly. We'd love to hear from you and would love to help you all adopt more AI usage. Thanks, everyone. Have a great day.